Hi, welcome back to AQA Certificate Further Mathematics GCSE. Today we're on chapter 4.1, Solving Quadratic Functions. This is a grade A video. I hope you enjoy it, and let us start. So in chapter 3, we've talked about what is a quadratic function, and now we need to talk about how do we find the solution. There are three ways of solving it in general, two of which are non-calculator methods, and one of them is specifically for calculators, and that is the quadratic formula, which is very important for mathematics. And yeah, let's start talking about how to solve quadratics. Alright, so in this first example we have x squared plus 4x minus 32 equals 0. How should we solve this question? The first method that is non-calculator is called factorizing, and we've done that before. So right now I want you to factorize this equation. Doesn't matter what the right hand side is, just factorize this part, the left part, which is x squared plus 4x minus 32. It should take you about a minute or so. You can pause the video, but I have done it, and after factorizing you'll get x minus 8 multiplied by x plus 4 is equal to 0. And to our knowledge, in order to get 0 in a multiplication, one of the term must be 0, because if there aren't, then it's never gonna be equal to 0. So either x minus 8 is got to be 0 or x plus 4's got to be 0. So we can draw two equations out of this information, which is x minus 8 equals 0 and x plus 4 equals 0, both of which can be true, and either one of them will be enough to make this true. So now we have to solve x. For the first equation we can easily solve it as x equals 8, and for the right hand side, same deal, we can solve it as x equals negative 4. So this quadratic has two solutions, one of which is 8 and one of which is negative 4. This is how we solve quadratics. And if you remember that a parabola, which is a classic quadratic graph, looks like this, and the x-axis pretty much goes right here. This is for x squared function, but most of the time it looks kind of like this. It intersects the x-axis twice, and therefore if it's equal to 0, which means it intercepts the x-axis, there are 2 points usually, and that would be right. I need to change my pointer to red, right here and there. So there are two solutions. The smaller one is on the left, so negative 4 is right here. The larger one is on the right, which is 8. So this is the first method that I'm going to show you. So now for the second method, which is completing the square method. This is the exact same equation, but we have already got the answer, so we can check if this answer is correct or not. So what is completing the square? You might have heard that before. Basically, you are trying to make an equation into a square number plus a constant, which looks kind of like this. X plus something squared plus c is equal to this equation essentially. So we can draw, if we expand the side, we'll get that it is actually equal to x squared plus 2bx plus b squared plus c. And what you need to do is to find your like terms between these two equations and to solve the b and c. For the first term, the x squared term, you can do nothing about it because there aren't any useful information. For 4x and 2bx, we know that they must be equal because there is only one x term right here. So the coefficient must be the same, so 2b is actually equal to 4, and so you can draw equation so that b equals 2. That is the basics of solving these kind of equations. I think there's another chapter that requires you to do this as well, but I will talk about that late, like at that time. So yeah, that's you've found B. Now you have to find C. We know that these two terms are the constant terms because there aren't a variable x in it. So b squared plus c is equal to negative 32. So we can draw another equation to show that c is equal to negative 36. Just like that, you expand this bracket and yeah, you can get the answer, or you can just do b squared is equal to 4 plus c is equal to negative 32. Then you can draw that c is equal to negative 36. So now we've got these two, we can put down an equation that looks like this, where we have this equation turned into this form with the correct number in it. So we know that this is equal to this. So this is completing the square. Now we need to find out what is x. How do we solve that? We classically do the same thing as rearranging, and you move the 36 to the right, make it positive 36. Because this is x plus 2 bracket squared, you have to square root the whole thing, but like both sides. So it will result in something that looks like this, where we've moved the 36 over the right hand side, then we square root everything. The square cancels out the square root, and the square root goes on to 36. And if you're quick, you can get that x plus 2 is equal to 6. And so we can conclude that x must be equal to 4, because x plus 2 equals 6, 6 subtract by 2 is 4. So x is 4. Then what about the other one? Alright, back. Sorry, I cut the video for a minute, but now I'm back. So we know that x is equal to 4, but what about the other one? The other solution, actually, if you know about square and how they work, is that no matter what the root of the square is, which is currently 6, no matter if it's positive or negative, it will always result in a positive number because negative squared is positive. So actually, one of the roots is negative 6. And so we have yet another equation to fulfill, and we can find that x is actually equal to negative 8. Okay, so that is basically how you find a quadratic. And I'm back here for the first slide because I have made a giant mistake again. I messed up the positive and negative sign because I'm stupid, and so it is actually a positive x, positive 8 and a negative 4. So the answer is the other way around, which matches our second answer. This is my bad, and I'm sure people will be saying about, oh, you made a mistake again, but I've corrected it in time, and so I think you guys can stop leaving comments about I made a mistake. Alright, so after that mistake, now I'm going to show you the third method, which is the calculator method. So let us start. So here we have an equation, and in general we use we say a quadratic function as ax squared plus bx plus c. This is how we normally write quadratic to show that it is. So in this case we can draw some equations. A is equal to 5, B is equal to 12, and C is equal to 3. Kind of simple, right? Well, what does it achieve? Now we can use the quadratic equation because we have A, B, and C. The fact that x is equal to negative b plus or minus root of b squared minus 4ac over 2a. This is the quadratic formula. It is given to you on the exam paper, so you don't need to remember it, but it is well worth remembering it because it saves you the time that you have flipped across to copy the equation. It's just time wasting. Okay, so now we have these variables, we have this equation. What do we do next? It's kind of obvious, is to substitute every single thing into the equation. And so you should get negative 12 plus or minus the root of 12 squared minus 4 times 5 times 3 over 2 times 5, which after you have simplified, you should get negative 12 plus or minus root 84 over 10. This is the most simplified way of writing x, but it's not. Do you know why? Because root 84 is divisible by 4, and therefore we can extract this out of the equation to get 2 root 21. Then you factorize the top to get 2 times negative 6 plus or minus root 21, and you basically simplify the whole thing down into negative 6 plus or minus root 21 over 5. This is how we always simplify the numbers as far as we can before we put into the calculator, because it's we know it's right. Sometimes when the calculator does its own thing, like if you forget a bracket in a specific place, it will completely ruin the result. And so either you are really careful at bracketing every single thing, or just simplify it on a piece of paper before you do your calculation. And for this specific plus or minus sign, it's basically mean it can be either plus or either minus. So in the plus case, the number will be larger because this root, how should I say, if this root is a positive number, then this whole thing will be larger. If this root is a negative number, the whole thing will be smaller. So if you can use your calculator, type in the following or this specific thing, you have to calculate twice, once with plus, once with minus, and you should get 2 results. And I'll wait. Well, you guys can pause the video and check out the answer before I show it on the screen, which is right now. So the answer to x will be negative 0.283 or negative 2.12, both of which in 3 significant figures. And so this is all for solving quadratics, because that is all the 3 methods that you will need to solve a quadratic. So my tip for you is that always try to factorize before you try completing the square, because that factorizing is much easier and you don't need to deal with square root or anything like that. But if it is not possible to be factorized, just completing the square really helps. For the second point is that you have to remember that for a root, it can be positive or negative, so whenever you do square root, do a plus or minus sign to remind you that it can be positive or negative. So here are 4 questions that I want you to answer is to find the solution or the root of these equations, or rather I want you to find the x value where these lots become 0. So yeah, and I'll wait for a few seconds and I'll reveal the answer. So here we go, we have 4 answers. One of them is just 1 because there's only one root to that. There's only one solution to that quadratic equation. And so yeah, that's it for this video. I hope you've learned something. If you did, leave me a like, helps me out a lot, and I will see you next time.